is LukePerko reporting live from the Bishop Kelly newsroom. Today we are celebrating the 40th anniversary of Thomas R. Cech's important contribution to the world of science. Dr. Cech was born December 8, 1947 in Chicago, Illinois. He grew up in Iowa City, Iowa, and always remembers wanting to be a scientist even when he was in elementary school. He graduated from Grinnell College in 1970 and then obtained his PhD in chemistry from the University of California at Berkeley. He has been on the faculty at University of Colorado since 1978. His research led to many awards, including the Nobel Prize in Chemistry in 1989. It's also interesting that his wife is also a scientist and provided him with the necessary materials for his most important research project. He also researches the telomerase enzyme that affects the telomeric sequences at the end of chromosomes. Dr. Cech researched ribonucleic acid in living cells. In 1982, he discovered that RNA molecules in a unicellular organism, Tetrahymena thermophila, could splice itself without an enzyme. At the time of his discovery, the popular scientific theory was that nucleic acids only functioned as the molecules of heredity. Proteins were thought to be the molecules of function and biocatalysts. At that time, all enzymes were considered to be proteins. That was until Thomas Cech discovered ribozymes. A ribozyme is a particle of RNA that has enzyme activity. He proved that RNA can both hold genetic information and function as an enzyme. I was able to sit down with Dr. Cech recently to talk about his amazing discovery. Dr. Cech, could you explain to us how your discovery has changed what we know about the DNA and RNA in the 1980s?
Because after all, the central dogma, as described by Francis Crick, is that DNA makes RNA makes protein, and that's still true. We didn't disprove that. We just found that protein isn't the only player in terms of cellular molecules that's able to speed up very specific biological reactions, that the middle guy in that stream, in the DNA makes RNA makes protein string, also can have the activity of being able to speed up biological reactions.
What exactly is so amazing about the RNA molecule, and how does its ability to bond with itself change shape and allow it to have enzyme activity?
The RNA is just a single chain. However, that is important. And you're saying, why is that so important? Well, because when the nucleic acid is relieved of the constraint of being sort of lockstep with another strand in a double helix, it's free to take on all kinds of shapes because it can interact with other parts of itself. So the structures that RNA can achieve have a wonderful variety, more on the order of what a polypeptide or a protein molecule can achieve. And this is what allows RNA to be a biocatalyst rather than simply an informational molecule.
Discovering ribozymes changed the scientific world. For one, ribozymes have contributed to our understanding of the origin of life. They have supported the belief that RNA may be the remnants of an ancient world that existed before the evolution of proteins and even DNA. Some experts have proposed that due to Dr. Cech's discovery of the ribozyme, RNA may have been one of the molecules at the origin of life, since it's a molecule that can code genetic information and also has enzymatic activity. Dr. Cech's discovery may also play an important role in areas of therapeutic medicine. Synthetic ribozymes are also being considered as treatment agents for diseases such as Alzheimer's, Huntington's, and Parkinson's disease. Ribozymes may also be able to serve as biosensors and will likely serve as a useful tool in gene therapy research.